Yeah, it's your boy, Young and C² at the house. It's so dirty you're gonna need a shower for this. Even Isaac Newton is here. Damn! Einstein, where you at? We throwing this down dirty. Yeah! Watch this on your TV. Not the cable, fool. Get the HD.
Hey yo, give a shout out to my girl, Dr. Hood. Where you at, girl? This is for you, alright?
Alright, so here it goes. So, walking down the street, just mind my own business, with some young punk was like, yo, you suck at physics. And I says, what? You don't mean me. I go to math school. Yeah, I take the AP.
Tell him, boy, tell him.
Oh, I will. In fact, I says, I got a little problem here that maybe you can solve. There's a 9mm hanging here tucked in my jaw. Got the mass, acceleration, and the forces, see? H-I-J-K-L-M-N-O-P. I got my Glock hand. This rhyme is insane, and your boy shot the hater on top the inclined plane. Oh yeah, that plane? It was frictionless, of course.
Frictionless!
So riddle me this, all you Newton wannabes out there. How fast was my bullet moving flying through the air? It's really quite simple with a bit of physics, see? This gangster knows it all from Maths Academy. Period 3. Yeah!
Take it away, white boy!
Well, what we have here is a perfectly inelastic collision consisting of two separate masses, the bullet, M1, and the hater, M2, which combine upon impact to form a single projectile that travels a distance x over a cliff with a height of y. Our goal is to find the bullet's initial velocity upon impact using the following values. The problem will demonstrate the law of conservation of momentum. As shown here, the bullet and the hater form a projectile with a change in height y represented as a function of time. Thus, y equals -1/2 g delta t squared. Solving the expression for t yields the following for the change in time during the hater's fall from the top of the cliff. Let's think about this. If the hater is stationary when the homie's bullet hits him in the chest, the transfer of energy will yield a resultant combined velocity in that same direction when they collide, i.e. Newton's first law. So let's call the velocity of the pair over the cliff in the x, that's horizontal direction, big V. Since the change in distance equals velocity times time, solving our expression for the variable big V yields the following. From earlier, we already know that delta t equals the square root of -2 delta y over g, so comparing the two simply means flipping the values inside the radical, giving us delta x square root of g over -2 delta y. Let's remember also that since this is an isolated system, we can apply the law of conservation of momentum to our collision, which states that momentum changes are equal in magnitude and opposite in direction. Essentially, even though our bullet lost momentum because it is now lodged in the hater, momentum was gained by the force of the bullet on the hater, and thus the total amount is conserved. Our equation then becomes as follows, with the two masses m1 and m2 multiplied by our momentum constant, big V, and compared to the mass of the bullet. All we've really done is taken a basic physics concept, delta x equals v delta t, and applied it to the law of conservation of momentum to attain values for each part. What we want to do is use the values we discovered for delta x and delta t to find big V, that is, the constant velocity from just after our collision. Then we stick it all together using our given information, and substitute known values. From here on out, it's just a simple matter of algebra, and you can solve that by either having a TI-89 or taking the class and actually paying attention. I would recommend paying attention. Don't forget your units. Dr. Hood's really big on those, and she failed me one time for not having them. A lot of times, actually. So that's pretty much it from this white boy's point of view. 276.755 meters per second is our final answer. Booyah!
Hey yo, is white boy back? Make white boy dance. Dance, white boy. Dance. Hey yo, why you upside down like a spider monkey? Get down from there, boy.
Yeah, you know you thug when you got gang tats like this. Haha. Alright, Chuck, let me kill it. Yeah. Y'all fool, you have it. Any player can see. We do real big in Arms Period 3. Rolling 25, tote guns galore. Check my gang tats if you want to see some more. Meet with the style, skills, and technique. Not just momentarily, but week after week. Roll with the boy, cause spreads beyond that. Stick it to the police and peace, son. We out. Mass Academy.